Okay, so inverse functions, the notation is f inverse of x. Very similar to when you have sine inverse, cos inverse, tan inverse. This does not mean to the power of -1. It means the inverse function. If you find the point both on the original function and on the inverse function, it's called an invariant point. It means it was unaltered by any transformation. So if I look, here's the f of x function, and here's the f inverse function. So f at 4, so if I go to 4 and find for f, it gets 7. If I want to do the inverse function at 7, I'm going to go look down, and at 7, the inverse function would be 4. If I look, I want to do f at 8. So f at 8 is 11. If I look at f inverse at 11, I get 8. If I do f at -6, so at -6 I get 0. If I do f inverse at 0, I get -6. If I do -9 for f, so at -9, I get -6. So f inverse at -6 will be -9. So let's create a table of values before both the inverse and the original function. So what I want to do is I want to pick key values. So I'm going to pick this one, this one, this one, and that one. So for the original function, at -10, we're at -8. At -3, we're at 6. At 4, we're at 7. And at 10, I'm at 13. If I look at the inverse function, I have a point here, 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 and here. Okay, and I want to read those points off. And I'm going to go again left to right. So at -8, I'm at -10. At 6, I'm at -3. At 7, I'm at 4. And at 13, I'm at 10. So what did I notice? Well, I noticed that the x values and the y values are switched. And that's how you know you've got the inverse. So let's look at this one. So I have this graph. I have a point here, 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 and here. So that is my f of x. So this is y is equal to f of x. And I'm going to record those points in my table of values. So this is y is equal to f of x. So I have -4 and 3, -2 minus 3, 1 minus 2, 2 minus 4, and 5 minus 2. So if I wanted to create the inverse function, all these y values become x. all these x values become y. Now I'm going to graph this new function on my grid. So I have 1, 2, 3, 1, 2, 3, 4. I have 1, 2, 3, 1, 2. 1, 2, and 1. 1, 2, 3, 4, 1, 2. And 2, 1, 2, 3, 4, 5. Since none of the points change, there are no invariant points, or since none of the points stay the same, there are no invariant points. Another cool and interesting fact about inverse functions is that they are symmetrical over the line y is equal to x. So I'm going to put in the line y is equal to x. These are the same distance from that line, from the inverse to the original. So this is the line y is equal to x. And if you look, it's like a mirror image from one side to the other. This is y is equal to f inverse of x. So if I write that down, the inverse function and the original function are reflections in the line y is equal to x.